Let X be the set containing 1, 3, and 5, and Y is the set containing S, T, U, and V. Define the function f from x to y by the following arrow diagram. Write the domain of f and the codomain of f. Now, the domain of f is the left side of this arrow diagram. It's specifically the set x. The codomain of f is the right side of the arrow diagram, which consists of the letters S, T, U, and V. And that's the answer to part A. Part B says, find f of 1. Now, we have an arrow diagram, and the way the arrow diagram works is that the thing in the parentheses represents the input, which is found from the domain of the function, which is the left side of this arrow diagram. Now, that is just this 1 here in the parentheses. We need to find f of 1, and f of 1 is not the same thing as 1. F of 1 corresponds to the output of this function. So we start from our input here on the left side, and we follow the one and only arrow to the letter V. So that means f of 1 equals V. Similarly, f of 3 can be found by finding first 3 on the arrow diagram on the left. And from 3, if we follow this arrow, we get the output S. And then f of 5 can be found by starting at the input 5 and following the arrow to the output V again. So that's the answer for part B. Part C, what is the range of f? Now keep in mind that the range and the codomain are not the same thing. The range is the set of all outputs. Now if you notice here, there are 3 outputs, and 2 of the outputs are the same. And so if we were to write out the set of all outputs of this function, there would only be 2 letters, V and S. So that is the range of the function. And notice that it's different from the codomain. There are elements in the codomain that are not actually outputs of the function. That'll be important to understand for later on. Part D, is 3 an inverse image of S? So an inverse image of S is simply an input that is mapped to S. And if we look at 3, we can notice that 3 is mapped, meaning that there's an arrow from 3 to the letter S. And so the answer to the first question is yes. 3 is an inverse image of S because the output corresponding to the input 3 is 1 an inverse image of U. Well, U is not even an output of this function. It's in the codomain, but it's not an output of this function. And so to answer this question, what we're really asking is, if we plug in 1, do we get the letter U? But the answer is no. We actually get the letter V, not the letter U. And so the answer to the second part of this question is no. Now, part E is asking, what is the inverse image of S? There is a huge difference between an inverse image and the inverse image. An inverse image is an element of the inverse image, which is a set. So that means that the inverse image of S is actually a set containing 3. Notice how that's not the same thing as just 3 by itself. Our answer here is a set. And then what about the inverse image of U? Well, there are no elements that are mapped to U, so this would be the empty set. And then the inverse image of V contains 2 elements because there are 2 inputs that are mapped to V, which is 1 and 5. And so those are the inverse images. Then it says represent F as a set of ordered pairs. Now, there are 2 pictures or diagrams of the function f. There's this arrow diagram, and here's another diagram illustrating all of the inputs and their corresponding outputs of this function. And we can turn both of these into a set of ordered pairs. So when we say f of 1 equals v, this corresponds to an ordered pair, 1, v. We'll get more into details about what this really means when we get into relations. And so f of 1 equals v can be represented as an ordered pair, 1, v. F of 3 equals s can be represented by 3, s. The input is the first coordinate, the output is the second coordinate. And lastly, we have 5, v. Now, these 3 ordered pairs correspond to 3 arrows in the arrow diagram. And that's how we know that we have the right set of ordered pairs here. Now, the way this is written, this is not a set. Our answer should be a set of ordered pairs. So we just have to imagine creating a set with these ordered pairs as elements. And so that's the answer to this question. Thanks, everyone, and I'll see you in the next video.